together now to kind of try to figure that out. Okay? First, we're going to talk a little bit about some classes, though. I want to take a little hash out, although we're going to discuss it as well. I'm waiting for some dramatic music. Today we're going to be combining nomenclature, and you have two things to do. Stuff can be handed in us a month later, okay? Or at the end of the day. Oh, it's really hard to turn that off. Listen to it all the time. You ever play that music? You want to walk, if you walk slowly, like you can fake like a slow walk, and it's just very dramatic. Like for anything, like I'm gonna go get some, bread in my kitchen. It's dramatic. It's epic. All right. So, what to take after chemistry? And there are many options. I just leave it on that way. You can only take AP chemistry. There are AP chemistry. That's grade indexed. AP biology. That's grade indexed. AP physics 1. Grade index. General anatomy, 4 NWTC credits. AP environmental science, grade indexed. You have physics, you have intro to physics, that's a new class next year. Earth science, and you have basic anatomy. We're going to talk on a few of these in more detail, but try to quickly just briefly talk about all of them as we are going to try to tell all the classes today. It's important to get information. It's important to talk to the teachers. It's important to talk to other students in the classes as well to get a realistic view of what it is. Please be mindful of certain people's, mindsets and their approaches. If it's not the same as yours and they have a negative outlook, that doesn't mean necessarily it's negative. If they have a really positive outlook on something, maybe they really loved that topic and maybe that's not suitable or fits you as well. So you got to have to kind of think about the audience that you're asking as well. So basic anatomy. Anatomy and basic anatomy. Both are dealing with the human body, talking about muscles and bones and organs and being very specific, labeling and function, and there's a lot of memorization because it's understanding all the little parts of that. If you're interested in going into anything that deals with the medical field at all, at some point you're going to have to run into this. So sometimes it's a nice idea to get exposure to this now, like in high school. The difference is, besides the NWTC credits, is that general anatomy is a more accelerated course than basic anatomy. I do not believe also, I don't know this for a fact, but I think this is accurate, that basic anatomy you do not get to work with a cadaver at NWTC. General anatomy you do a little bit, which is a really cool real life lessons for you and applications. I remember I got to do that in college and it was still one of the most memorable learning experiences I ever had. In a 2-month period, we went from the cadaver, full skin, down to the muscles, down to less muscles, down to its organs, down to just its bones. And we got to study all that, and it was an amazing thing. That's with Mr. Anderson, so again, get some information from him and or other students. Some of you might be in it now. Anyway, that's basic anatomy. We have earth science. I think it's actually earth and space sciences, plate tectonics, volcanoes, some earth systems, weather patterns, some different planetary studies as well. So if you're interested in that, that's definitely the path you want to go down. We are getting rid of lab science. The way that the state requirements have taken us and student requests and offerings, we're changing it into a more accelerated course called 2 semesters worth, called Intro to Chemistry, which you're not allowed to go into because you're already in chemistry. And the other semester is Intro to Physics. So if you're interested, like, you know what, I think I might like physics, but I'm not sure, or my schedule only allows me for a small window here, but I want to get a taste of it, Intro to Physics might be your calling on that one. See what it's all about. It's a semester course, so it gives you the basics of physics. It won't go in as depth at all as the actual physics class, but it will definitely give you a nice little overview of physics. AP Biology, that's taught by Mrs. Verts. That is, I'm uncomfortable. I don't know how to speak on that too much. I'm not as familiar with it. It's anywhere from plants and all the studies of the plants and the animal systems and a lot of human systems. I mean, anywhere from even just understanding the intricacies of changing different kinds of electrolytes, different kinds of salts, and what that will do to your blood pressure, and how do we figure that out in genetics and all that kind of stuff. So AP Biology is that. AP Chemistry, is taught by a slightly off-stable guy. That is simulating a full year of chemistry. It's me. And that's simulating a full year of college chemistry, so first and second semester of a college course. And we study speeds of reactions, we study temperature, thermochemistry, so temperature exchanges, we study acid-base reactions, a lot of acid-base reactions. We do a chapter called electrochemistry, which is studying batteries and how a battery is actually created in the chemical process in a battery. We go further into depth on actual reactions. And what's actually interesting about it is that we use, for probably about half the chapters have about half of the material from first chem. So it's not all completely fresh. It's not like, whoa, it's all completely starting with all new material. We build off of what we've all learned. And then I will let Mr. Blackford discuss other two classes.
Three, as you can see, three different physics offerings. The intro to physics, I really would say that that's not intended for students that are
probably in general chemistry.
Taking chemistry, but it's not that it's completely off limits, but that's not one that I would encourage you to take because it's more of a, I got to get my science credits and I want to do as little as possible type offering, in my opinion. But the regular physics and the AP Physics 1, neither one of them have any prerequisites other than your typical math background. They're both algebra based, neither of them are physics based. The AP Physics 1, like any AP Physics or AP class, is going to be more academically rigorous, more challenging, but they really cover the same types of content. They cover one-dimensional motion, two-dimensional motion, forces, Newton's laws, circular motion, projectiles, momentum, and energy. And then we get into waves to a small degree. In AP Physics, we have a small unit on electricity, electrostatics, and circuits. There is an AP Physics 2 class that nobody has gotten to yet, but it just started being offered. But that has AP Physics 1 as a prerequisite. And don't remember if he made reference to the AP Environmental Science, but the AP Physics 1 class is a year-long class that is equivalent to one semester of first-year college physics. So if you pass your AP Physics 1 exam, you tested out of the first semester of physics in college. And AP Physics 2 would be another one-year class that would be equivalent to another semester, or the second semester of intro college physics. But in any case, I think anybody in here, if you're in general chem, you certainly have the capabilities to take physics and or AP Physics if you are a little more motivated.
And AP Environmental Science is taught by Miss Tutt, and she that's another class. It's a full year, high school year, but it's simulating a semester of college work, and that's dealing more with maybe wind energy, solar energy, different worlds like carbon cycle and water cycle, and that's she gets into a lot of kind of cool projects, and you go into depth. I think it's a little more hands-on throughout the year. I think they used to at least do some field trips where they'd actually venture out to some of these sites and kind of study it in real time. So
do a lot of water quality.
Yeah, water quality tests. That's it. Yeah.
Water quality unit.
Regardless, all of these, if you're thinking, you got to look at your schedule and you got to think about what's good for me. Okay, I have like this many difficult classes, and you don't want to overwhelm yourself. You don't want to underwhelm yourself though either. We get emails a lot from students that have taken advanced classes. Even if I'll just speak personally, some kids in my AP chemistry classes who I wouldn't say were the top students in my class, they would write back and say how helpful taking a class like that was. It has nothing to do with me, it has to do with the class. Like the fact that they were able to get that rigor and get that feeling now, like whatever you're deciding, maybe in a different subject area, You want to get some of that feeling. When I went to high school, I didn't have any AP classes. They didn't exist in my school. But in Minnesota, it was like 10 years in advance. They already had it all down. And I went to school with a bunch of kids that had all these AP credits, like most people here now at Pulaski. And it was amazing to see the difference of some of these kids who I didn't think were exactly exceptionally brighter than anyone else, yet they seem to have it all figured out in college already. They seem to have the pacing and the studying down. When I had to kind of figure it out, I felt like I kind of got slapped in the face when I showed up, because I was like, whoa, and I felt like I was sprinting to keep up, and it kind of looked like they were just kind of easily striding and walking because they've already been through it and they understood. I see that in AP Chem in the first month and a half. Within a month and a half, kids are already like, oh, okay, like this, I figured out my pacing. Like I still have life balance, but you have to be in it. You can't figure it out until you're doing it. So whatever you're doing, if it's not science, it's something else, we do encourage you to take a couple of classes that are going to give you a little bit of a challenge. Because again, you're 15, 16, or 17, let's say right now, that's great. But what do you want to be when you're 22 or 23 or 28? And sometimes setting challenges and figuring out what you're capable of doing, it's important to do it even when you're not wanting to do it now. It's a sad thing when you look back and see the kid who was apathetic when you're 28 and wish that you could have talked to them and said, you know what, you should have tried a little harder, or given yourself at least a challenge because you knew you were good enough, but you just were too lazy. Figure it out. Try it. Give yourself a shot. So again, if you have any questions, let us know. We can try to help you out. We're not going to say you must take this class. That's not what that's about. Do have a realistic view though. You need 3 science credits. So make sure you do have those. So, all right.
One last thing to add. Obviously, the AP physics or the AP classes are more in-depth, more advanced, but physics is going to be very much like chemistry in terms of it's a lab-based class. There's a lot of labs. With chemistry, I think it's cool because you mix stuff together, you can't really see what's happening. All of a sudden, you've got bubbles and different solutions and stuff that gets hot. And Mr. Gus is going to do a cool demonstration for you today. With physics, we're working with more large-scale, macroscopic objects, Hot Wheels cars, and dart guns, and flying pigs, and a lot of toys, but it's still lab-based.
That's not fair. How can I compete with that? Legos and Minecraft. All right. So please, I think we do it in a week. You have to sign up within a week. Do be mindful. You can always change your mind eventually too. So if all of a sudden something doesn't work out, it's not like you have to be committed right then and you have to go that way. All right, so let's get our note sheet out. We're going to do the landscape sheet first. Here's my goal for you. By the end of today, you have a better idea of how to figure out how to name the compounds when they're all mixed up. Okay, so up to this point, what we have done is we have given you a worksheet that said here, covalent compounds go. And then here, ionic. And then yesterday, here's an acid worksheet. But what happens when we mix them all up? So, I believe these notes, that this is minimal notes. Because I wanted to try to streamline this as much as possible. We want you to have the ideas of what are the big picture ideas when I run into each problem, not having to try to memorize all these little small intricacies, okay? So, here's how we're going to have this. This will be a nice little quick study guide sheet for you. When I see a compound, my first thoughts, like this is just what I'm thinking about, what I need to recognize. If it's covalent, what I'm going to see maybe are prefixes. And I'm sorry these are a little smaller. Hopefully you can read them in the back. I didn't realize they were as small as they appear. You got to keep in mind today, and the rest of this year, you don't cross prefixes, okay? If you're seeing it in formula, in the formula instead of the name, you're going to notice that it's a non-metal first. Honestly, the other one's always going to be non-metal as well, but the first one's going to be a non-metal. So that's what I'm seeing. That will trigger, this will trigger what I have to do down here. These are my actual rules. So this is what we learned the other day. There are 2 parts to a covalent compound, the first word and the second one. There's 2 different elements in them. So the first one, we always do the full name, and if there is more than one atom, we got to use a prefix. Okay. For the second compound, or sorry, atom, we're going to end the word in "ide," and you always, please stress that, because this will make or break a lot of your points, you always have to use a prefix. And that's it for covalent. I know it's been a while now, but when we went back to that, when we were learning that, I think a lot of people felt like there wasn't a lot of rules to that. There aren't. Unfortunately, ionic, there are. So at least if there's 3 of them, only one of them is somewhat complicated. The other ones have a lot less rules to follow. So what if I run into something that I think is ionic? This is how I would know it's ionic. I would notice that there are charges. What do we do with charges? Come on. We crisscross. Another way that I know it's ionic, it starts with a metal. So those are the things that I'm going to recognize as well. All right, so rules, there's a few more, but try to streamline them as much as possible for you. Again, first one, you do have a full name. But you will need a Roman numeral if that element is a transition metal. Now I know there's a few exceptions and things like that, like tin and lead are not a transition metal, but we're trying to hit big picture today. Second one, we still have I. And then, it is really important, it's an imperative that every time you see, or you're working with polyatomic ions, when you cross, you use a parenthesis. Lastly, just Monday we learned about acids, and acids kind of fell into 2 categories. The first category, whoops, getting ahead of myself. I only did this because the other 2 had to have this box. If you don't know it's an acid, to me, then we're not really paying attention to it. Because here are your hints. It starts with an H, or it has the word acid in it. I mean, that's it. There's nothing else I can say. Like, well, what about other ones that have starts with an H? Not in the compounds that we're learning about. Only the ones that start with an H will be an acid. Okay, so that's all we have to worry about. But there are 2 categories. First one, if it only has 2 atoms. The other one's if it's 3 or more. So the one with 2 atoms, although it's the shortest one, it actually has a longer name usually. What we need, and this is just signifying to be H and something. Okay, so basically the name of our acid is hydroblanchic. Very dangerous acid. Need to wear goggles. If you have 3 or more atoms, gets a little more complicated, but very manageable. If you have 3 or more, you know you're using a polyatomic ion. Remember, you have a polyatomic ion sheet on your test that has the majority of polyatomic ions on it. And we will review the ones you have to memorize later today. So, we taught you 2 things. Simply put, if the polyatomic ion ends in 8, it goes to ick, like you ate something icky. And if it ends in ite, you go to us, or vice versa. If it ends in us, you're looking for something that ends in ite. And this is your choice if you want to write this last one down. The number of H's equal the negative charge. Most of them are H, just one H. There's few acids that have 2 H's and then very few acids that have 3. So, I was thinking, I think it'd be kind of cool to try to do a demo that deals with more than one kind of compound. So, I have an acid and a covalent compound and we're going to mix them together. Okay. Actually, I have 2 covalent compounds in an acid. So, what I have here is sucrose. Sucrose is a covalent compound. It just has carbon, hydrogen, and oxygen in it. It's a form of sugar. Okay. Here, I have sulfuric acid. 18 molar, which doesn't mean a lot to you yet, but just it's very, very, very dangerous. And I forgot my gloves. That's okay. Oh boy. It's like, no. All right. So, to show you what I'm going to be doing, oh, that's hot. This is wood, which is made up mainly of cellulose, which is carbon, hydrogen, and oxygen. And the minute I set it in there, it turns black immediately. And the reason why is that it is basically dehydrating or sucking out all of the water out of there. So it took out all the H's and the O's. All that stuff is carbon. To give you kind of a reference point, like charcoal, that's all that's left. It's just the charcoal of the wood now. It's just carbon. Okay? Well, what we're going to do is I'm going to simulate that. I'm going to simulate that or same concept with the sugar instead. So I hope you can see this beaker. I'm going to put just a little bit of water to get it kind of going here. Oh, sugar and water. A little bit more. Okay. And then all I'm going to do is pour the acid in, and I'm going to stir it. And I'm going to dehydrate the sugar. So I hope, if you can't see, try to move your head so you can. See this? I'm going to stir it. Now, this is not the fancy part. Bless you.
Wow. It looks like one.
All it is a charcoal. It's just charcoal now. It's just charcoal. And it really smells. Okay. I'll be right back. Alright, so all that was left was the carbon, and it took out all the hydrogen and the oxygen out of that. So, pretty cool.
I guess.
Alright, so there's one thing I need you to do. On the bottom, there's a very small opening on the bottom. I need to just show you 2 examples of this. It's very straightforward. We're talking about dehydrating and sugars and things like that. Well, it's called a hydrate. Okay? So let me show you 2 examples, and this will make a lot of sense. This is actually the only new material we're learning today. So you could have this. Just write this to the left. You might want to make a little title on the side that says just hydrate so you understand what you're looking at, but you don't necessarily have to. So here's the first one. Like, whoa, that's really long. There are certain compounds that are hydrated, which means that they have water attached to them. Other ones actually are not, are stripped of the water, and they're called an anhydrous. Don't worry about that phrase right now. But all we have to do is be able to read this idea. This little dot literally means with. So it's saying this compound is with that much water. So if you're drinking a bunch of fluids, a lot of water, you are trying to hydrate yourself, right? Because you feel dehydrated. So that phrase is really important to have down. So I'm not right now reviewing how to and why I name this, but I will anyway. I'm going to name this side, but I want to show you how we would just add this. So this is copper. I realize that copper is a transition metal, so I figure out the charge. That's copper 2. And then SO4 is either sulfate or sulfite. And it is sulfate. Okay, that's that part. The ending is really straightforward, and I hope you're going to find it very user-friendly. all you do is you say the prefix. So you say tetra, and then water is hydrate. That's it. So that's the name of it. And there is a space there, like between sulfate and tetrahydrate. I will do it the opposite direction once. Sorry if I'm in your way. If we were given a name like that, how would we do the formula? Okay, well, we just learned that if it's a metal, it's an ionic compound. Okay, so I'm thinking about charges then. So I know that this is 2 plus. The reason why I know it's 2 plus, it's on the periodic table. Whoops. Oh. It's on the periodic table, 1, 2. Chloride is 1 minus, so that's Cl minus. So what do I do with charges? I crisscross them. So this part is the MgCl2, and then all I do is put a dot. How many waters do I have? 2. I put a 2, and then hydrate's just H2O. And I'd be done. So that's something you're going to run into. The first part's not new. Regardless if we're struggling on that or not, we need to get better at it. The second part, all we do is say a prefix and the word hydrate. Okay? But speaking of naming and polyatomic ions and things, how are we doing on those? Memorizing polyatomic ions. Do you know nitrate and chloride and ammonium and sulfate and phosphate and nitrite and hypochlorite and hydroxide and perchlorate and chlorate and sulfite? Well, let's review. I'm going to leave this up here for a second. We're going to review on how we can remember these. You have until Monday. You're going to have to know them. Okay, so remember, determining the charge. Okay, I'm just going to try to do this slightly. What if you're given 2 of these names? I want to review on how you could do this without memorizing 11. What if I have nitrate, and you're going to have time to practice this in a second, and sulfite? All right, so how I do this? First, I got to determine the charge. So odd groups get a -1, even groups get a -2. If you're like, no, I'm just going to memorize these and I don't want these rules, that's fine, then memorize all 11. But I hope that if I see nitrate, I'm thinking, well, I know that's N and O. Like it's always the element and then O's for like 9 of them. Well, okay, nitrogen is in group 15. 15 is odd, so that automatically is going to get a -1 charge. Sulfite has S's and O's. S is in an even number, so an even group gets a -2 charge. That's step 1. Step 2, how many O's do I have? Frankly put, the bigger the charge, the more O's you have on the ones you're trying to memorize. Okay? You just got to remember which number you start with. So unfortunately, these two don't really follow our rules as much. So what do we do? -1, the 8s get 3, and -2, the 8s have 4. So this is an 8 with a -1, so that's a 3. A 2, 8 gets 4. But what does an 8 do versus an 8? An 8 has 1 less. So I said, oh, that has 4. Whoops, it's an 8. That has 3. Okay, so you're not going to have endless amount of time, but what we're going to do, this is for you. How many do you know? How many can you figure out right now? So Mr. Blackford's handing out some quizzes. They're for you. If you want to copy off somebody else, that is absolutely fantastic to copy off of somebody that it means nothing and you don't get any grade for it. Know where you're at. Which ones do you know? If you're doing this right now, which ones do you know? So then you can figure out which ones you need to study. So I'm going to give you about 5 or 6 minutes right now, and maybe 5, and do as many as you can. Do not look at a sheet. Do what you can. I'm going to leave this up here. If you can't figure some of them out, that's fine. But figure out as many as you can. But these are all of them. Yep. These are all 11 that you're supposed to know. These will not be supplied to you on the test. So, how many can you figure out? If you peek, then this is pointless. Try to do it without. You can look up on the board. Just try not to look at your polyatomic ion sheet. If you want to work with someone else, You find that's going to help you, fine. But we're trying to figure out if we know.
Anyone else not get one?
I had one up here too. I'll get it. When you are done or you've exhausted the amount that you can do, you can check yourself. There isn't another screen that shows all the answers. You have a Polytop guidance sheet that you should be able to look up. If you lose that, there's one online that you can reprint off if you need to, but I wouldn't do it until you're done. Check it out at the end, and then you know, what do I need to work on? Knowing these and not knowing these aren't going to make or break your entire test, but it definitely will, you'll feel it if you don't have these down. It's not like it's either an A or an F, but it definitely will be present on the test.
No cheating.
You've got 2 more minutes. When you're done, we're going to be going to the other side of your note sheet. Finish up there. All right, so check what you've done, or what you haven't done, and you can kind of see where you're at. And just be honest. It's the only way you're going to get better at it, okay? So we'll be practicing that throughout the rest of this week yet. You have until Monday to help you along. But I have 5 last examples to go through, then we're going to do a bunch on your worksheet that you have, and we'll get you off with some direction here. So on the back, there are 5 that look like this with some arrows, okay? Here's the thing. We're going to start mixing these up. And you need to understand how to get from here to here. So how do you go from formula to name? Sorry, other way around. Name to formula. And how do you go from formula back to name? So all I'm doing on the arrow are telling you the things that you should be thinking about or recognizing. And I'm not trying to choke you with extra notes. There are extra things we could always write. I'm trying to hit some different main topics on this to get you right and down the right path here. So here we go. Carbon disulfide. How do I get to CS2? I've already given you all the answers. That's not the question. Here's the thing. I see a prefix. Okay? I'm just drawing right on here. So, first off, prefix means that it's covalent, which that may enter your mind, that may not. But the bigger deal is, what do I do with prefixes? Cross, yes or no? No, I don't cross. It's the biggest thing I can tell you on that direction. If you don't do that, these should be fairly straightforward. Hey, sweet. Carbon, there's nothing in front. I see a die, so I know there's one of these and two of these. Done. Like, we should be very successful on those. Don't start crossing those. But, how do I go back the other way? How do I know that this is carbon disulfide and not carbon sulfide? Well, there's a couple big things to help us out with. Here's the biggest one. It's a nonmetal with a nonmetal. The second one's always going to be a nonmetal, so I know that's a little redundant. But the first one's a nonmetal. That carbon is a nonmetal. It's not a metal. So, because of that, sorry, I'm confused. Because it's a nonmetal, we got to use prefixes. So that's why it's carbon disulfide and not carbon sulfide. Like, wait, why would it be carbon sulfide? Well, if we're supposed to be using charges, then you don't use prefixes, so you just name it. So that's how you do that first one. All right. Next one. I'm going to go through each one pretty quickly here. Hopefully you're staying with me. All right, calcium chloride. How do we get the CaCl2? What I noticed there, no prefix. Like in the name, I don't see a prefix. So if I don't see a prefix, it's ionic, which means that you're using charges, right? So you crisscross. Okay? I don't see a prefix, so I must be using charges. You can't do both. Now there's a few polyatomic ions that have a prefix in them, but they end in 8s or 8s, so they help you out there. It's like, oh, that's an ionic compound. All right, how do I come back this other way, though, and know that it's not calcium dichloride and it's only calcium chloride? Here's the trick. The only thing that's going to help you. Right there. It's a metal and a nonmetal. If we are confused on where metals and nonmetals are, that's why we were working a lot on the periodic table. This little triangle is the nonmetals right there. That's it. That's a nonmetal. Calcium's way over here. It's an alkaline earth metal. All right, so because of that, no prefixes. Because of the metal, there are no prefixes. And that's it. Now it gets tricky when you have them all together, but this is the mechanism that you need to kind of go off of, okay? All right, next. Now I could restate all the same stuff here, but I want to state a couple new things that you might want to think about as well, okay? I see an 8. So this must be a polyatomic ion. So that is a clue. Bless you. That is a clue. Now, actually, the Roman numeral is also a clue. This right here tells me this is a charge. Just so you know that as well. All you got to do is figure out, am I crisscrossing or not? And the question shouldn't be, oh, is it an acid? It either starts with an H or it has acid in it. So these don't start with H's. So that's how I get there. Okay, I crisscrossed it. Again, there are rules. We've learned about parentheses and what the charges and all that. That's not what this is for. How do I come back the other way? How do I get to this? One big thing. And this one, besides, I'm not going to restate it again. Hey, it's a metal, so I know no prefixes. I see a transition metal. Nickel's a transition metal. It's in the middle. It's in the D block. So I must use Roman numerals. That's the first thing to point out. The other big thing that could help you, like immediately, there are parentheses. So that must mean no prefixes, because that's ionic. Here, I'm actually going to write that. Ionic. So no prefixes. If there's ever any parentheses, I must have been having a polyatomic ion in the name. Sorry, in the formula to get it into the name. What do we have? 2 left? All right. These last 2 go pretty quick. All right. Leave that bottom one up down there for a second if you're still writing. Hydrochloric acid to HCl. How do I get there? It's always a shame to see students mess some of these up because you haven't had as much time with these and you're just flipping it in your mind. So let's just try to get that straight. Okay, how do I know that it's just HCl? All right. Well, the idea is this. You see hydro. Okay? The minute hydro is there, what you know, it's only one atom with hydrogen. That's it. It's a binary acid. It's just one atom with hydrogen. Again, I know that it ends in ic and all that good stuff, but you just need to realize it's just HCl. That's all it is. How do I go back the other way on this? Well, simply put, again, it's just H and one thing. It's only 2 atoms. I know I'm repeating myself here, but you got to have hydro. The biggest deal on this one. If you notice that there's only 2 atoms, you got to have hydro. And that's the biggest challenge students have. When do I use hydro? When don't I use hydro? To be honest, there are so few hydro ones that if you don't know, don't put hydro. If you're like, I have no idea which one, I don't know, then don't put hydro on it. Like our last example. Chloric acid to HClO3. I did this on purpose. We had hydrochloric and then just chloric. So what's the point on this last one? No hydro. So it must be a polyatomic ion. So in this case, ic came from 8. So I'm looking up chlorate in this case. That's where your brain has to go. Okay, oh shoot, there's no hydro. Okay, that 8 to ic, I to us. All right, and then you make it. So this is chlorate right here. This is chlorate. All right, the fact that I see 3 or more atoms, no hydro. How do I get to the name? There's 3 or more atoms, so it's no hydro. And in this case, I use the polyatomic ion, and this time 8 simply went to ic. And I don't actually have more to write. It looks like I was going to. So chlorate becomes chloric, right? So those are the mechanisms that we need to have down. So we're going to practice this a little bit. Right now, I'm going to do some problems for you. People saying it's a lot. Am I hearing it's a lot? Yeah.
It looks like a lot.
It's a lot, yeah. Your predecessors, meaning students before you, their first worksheet had 190 on there instead of 46.
Yeah, how many?
190. You instead, we broke it down into multiple worksheets. You will have a new worksheet for the next 3 straight days.
Oh, that's nice.
In class, the next 2 days, keep the head up. Good, strong. I learned the other day about stress and letting it work for me. My body's getting ready to do nomenclature. Okay? The next 2 days in class, we are working on this and this only. Meaning, like, literally, what questions do you have? Want to work with others? You want help from us? Okay, we aren't sitting down and putting more notes on the board or anything else. We'll help you with a few at the beginning of each period, and then it's your time to maximize it. So this will do at the end of the day tomorrow, but no, there's another one coming. Okay? It's a scientific fact that you need a certain number to get this accurately right. I think it's actually 186 is the number. Some of them.
So you just went over it.
No, well, we might tone it down just a little. Let's do a few of these together. You first off, suggestion. A lot of people like to use a highlighter on these. You can circle them or whatever else you'd like to. You got to try to identify, is it ionic, covalent, or an acid? Secondly, suggestion for this, because it's really a tight space, you might want to put your answers in alternating spots, or like every 3, kind of move them down so they aren't right on top of each other. It's just a suggestion. You don't have to do that. But I want to talk about a couple of these. So number 1, I'm going to do a bunch in a row here. I'll do it down here. You probably all know what carbon dioxide looks like, but it helps with just how you're supposed to recognize this. The fact that I see prefixes tells me that it's covalent. So I'd circle covalent. Remember, covalent, prefixes. No prefixes, ionic, because then I'm with charges. So that's covalent. So then what do? Do I cross prefixes? No, I do not. So I just bring them straight down. So that just becomes CO2. Right? It just goes straight down. But you go to number 2, mercury 1 chloride. Now, with the names, you don't have to recognize that that's a metal. I don't see a prefix. So if I don't see prefixes, I must be doing charges. It's where your brain has to make a huge separate division and understand that that's the key to success in this. Am I doing prefixes or am I doing charges? So I'm doing charges here. So you have to figure out the charges and crisscross them. That's all. Well, one of them was already given to me. Mercury is +1. What's the chlorine? -1. So it's mercury +1, chlorine -1. Hey, they offset. So it's just HgCl. If you wrote Me, I'm sorry. That's not mercury. Number 3, phosphorus pentachloride. Ionic, covalent, and acid. What is that one? Covalent. I love covalent ones because I don't even have to look up charges. The formula is PCl5 because I just bring the charges, or the prefixes straight down. All right, I got about 3 more I want to do. I'm skipping to 5, so please be careful. Don't. If you didn't know, we're not expecting you to know this. You want to look at the periodic table for just 1 second. SB is clearly not one of them that has a Roman numeral that we've taught you. But if you're ever told it has a Roman numeral, don't question it. They've helped you out on the charge. So antimony is SB, and you'd have a periodic table, look that up. And it's a 3 charge. Fluorine has a -1. So it'd be SB. Cl3. All right, I got 2 more I need to do with you, or maybe 3 depending on. You get down to number 7. It's our first acid. Okay? It doesn't have hydro. That's what I'm noticing. Gosh, by the time I'm done, you're not even going to have enough problems to work on. Yeah?
Is it SbCl3?
Oh, is it an F? I'm sorry. Is it fluorine? Thank you. Good catch. All right, so phosphoric acid. What am I looking up? What does that mean, phosphoric? It means it comes from phosphate. Phosphate. Phosphate is PO. Even if you can remember, the phosphate has a 3- charge. Anything that's bigger than a -1 charge for 8s have 4 O's. So that's PO4 3-. So what's my formula? PO4 3-. H3 PO4. Why the 3? Because it has to offset the -3. Okay? Alright. Let's try to go the other direction. I'd like to do 2 more down there. And then we'll look at the back.
There's no back.
Number 26. Last 2. 26. So this is where it all comes together. How do I name it when I'm not being told it's ionic, covalent, or whatever? All right, you got to recognize what your mechanism is. What are you trying to figure out? What I'm trying to look at is if it has a parenthesis or polyatomic ion. I know that's not the one we're doing. Well, that's clearly then charges. But here, there's nothing to give me a hint. But there is. The first element. Is it a metal or is it a non-metal? If it's a metal, you're doing charges. If it's a non-metal, you're doing prefixes. So this is a non-metal. So all I'm doing is prefixes. So I see that there's P2, so there's 2 of them. So that's di, and then, like I've done before, full name. So it's diphosphorus. And then the ending, and I'm not too worried about you freaking out about vowels or not. Let's just put them both on there. There's 5, so it's penta, and then you drop the ending and add IDE, so pentaoxide. Diphosphorus pentaoxide. We'll end on 32. And again, some of these are going to trip you up for a while. This is why we're practicing for the next 2 days still and the whole weekend. CuCl2. Prefixes? No, it's a metal. So, okay, so full first name. Just have to try to bring this all back. When it's a metal, I have to pause and go, wait, do I need a Roman numeral?
Yes.
You just have to ask yourself that every single time. It is in the D block, so I need one. I'll come back to that. Where am I? And then I finish it. It's not dichloride because I'm not doing prefixes. You're either doing charges or you're doing prefixes. So it's just chloride. How do I figure that out? You reverse cross, right? So the 2 just goes back up. So copper 2. Copper 2. If you forgot the Roman numeral, it's not the end of the world. You get some partial credit. Please, if you'd like, you can hand in your Nomenclature 3 and your labette now or by the end of the day. Don't forget though, if you'd like to hand it in now, you can just bring it up here. There's piles for B, G, and N. Make sure your names are on it.
Please exit to the left.
Yeah, Mr. Anderson's classes come in here next, so we still have a minute. Would you like to hand that in now? Yes, we can. You guys turn off the blackboard?
Hang on.
Hey, don't turn in your lap.
I like to know.